Good morning, viewers. In the earlier sessions, we have seen the basic constructs of C, control statements, arrays, and then functions in C programming. In this session, let us concentrate on structures in C programming. The course code for this particular course is MCS 011, and today we are having the session on block 3 unit 9 structures in C programming. I am Professor V.V. Subrahmanyam, Director, School of Computer and Information Sciences. So before going to the definition of structures in C programming, let us just recap what we have seen. So we have seen so far the store numbers, how to store the numbers, how to store the characters, strings, and large sets of these primitive using arrays, and then how to declare these particular variables using the appropriate data types. Likewise, the illustrations of the programs that we have seen in the earlier session. In this session, let us concentrate on an important topic, that is structures in C programming. This particular topic will be very useful while doing your data structures course also. This topic, then pointers, and then file handling techniques, these are the important chapters that you have to concentrate upon, because these will be used by you in data in the future courses like MCS 21, that is data structures, and then in the third semester you have design and analysis of algorithms also. There also you have to write certain programs using C. So these particular things you have to have a good foundation so that you can cope up the other courses very well. So whenever you want to use a variable in C programming, we have to first of all declare it in the declaration section that we had already seen. So we had talked upon 4 data types, that is integer, character, then float, double. These are the 4 primitive data types we had talked about. And then in the earlier session we had talked about the user defined data type called as arrays also. So instead of declaring, like whenever there are, we had seen the example also wherein which if there are several identical data items under same category, instead of declaring several variables, like take for example English marks for 40 students. So there you have to store 40 students English marks of the same class and section. So instead of declaring 40 variables, we had introduced array concept. So array is nothing but a simple identifier name with some index, and then that index we told you that it starts from 0. So English of 40, if at all we had declared it as an integer variable, then it starts from English of 0 till English of 39. So it will store all the 40 students English marks. Suppose if there is a case wherein which you have to store the whole record. Here I am talking about a student's record. That means the student's name, enrollment number, marks for 5 different subjects, total, average, and grade. So these are the data items that needs to be stored as a single identity. So there is no need of doing a separate declarations for all these variables, because it will create a chaos in the programming. For these kinds of things, we use a different kind of construct, that is the structures. So whenever you want to store collections of different kinds of data as single data entity that are somehow related. Here we are talking about one student. Likewise, all the 40 students' records of similar kind needs to be stored. So for this, a construct is there, that is the structure construct. So another example we can take here is the employee with his name, age, designation, department, salary, under which supervisor he is working, like where the branch is situated, which state. Likewise, you can create a single entity for an employee with all these data items, or else you can call them as the members of the structure and put it as a single entity. So this structure can be defined as an user defined data type, like the arrays. This doesn't comes under the primitive data type. However, all the primitive data types we can use it in the structure. It can hold group of data of different data types, and those data types can be int, character, float, double, long double. So all these data types can be grouped and can be held in a single structure. It contains any of the C data types, like including arrays and other structures also. That also we will see in the later part of the session. Each variable within a structure is called as the member of the structure. So each and every variable, whatever we are declaring inside the structure, is called as the member of the structure. Let us see the syntax of this structure. struct is the keyword that we have to use. That is compulsory in order to declare that this is a structure. So struct, the keyword we have to use, and then structure tag. Here user can give any name. You can see here structure tag. Suppose if you want to create the structure for a student, you can use student, or for employee, employee. Likewise, you can use any name, just we give it for the variables. Likewise, the structure tag can be defined by the user. Once again, the curl brace opens. So inside the curl brace, you have to declare all the variables with appropriate data types. Suppose if student's name you have to declare, data type it will be a character. It is nothing but a character array. So you have to take an appropriate data type for each and every variable, whatever you declare inside. So this structure should end with the curl brace, then semicolon. That is the delimiter for this particular structure. So once again, you just look, the keyword we have to use in order to declare the structure. Struct is the keyword, then structure tag is the name. You have to open the curl brace, declare all the variables concerned to that entity, then end it with the curl brace, then semicolon. So this particular structure, whenever you declare, this acts like a simple layout, or else you can call it as a simple template, or else a blueprint. So this is the kind of record that you are going to store under the structure tag's name. So that you have to remember. This is only just a declaration. We are not assigning any variable, or we are not assigning any space for it. We are just showing the blueprint here that this is the kind of structure we are declaring in the C, and then we will be using it during the programming. So let us see a simple example. This is just remember the syntax. We'll follow with the example. Here struct is the keyword we had used, student is the structure tag, then integer roll number, then name is a character array. We had given the size as 20, then character course with size 10, this is also a character array, then integer marks obtained, then close it with the curl brace, semicolon. So here, whatever the data type that we are declaring here, appropriate data type for the variables, roll number is an integer, so it occupies 2 bytes. then name 20, so 20, then character 20, then integer marks obtained. Once again it is an integer, it occupies 2 bytes. So just count 2 plus 22 plus 10, 32 plus 2, 34. So if you declare a variable of this student, each and every variable occupies 34 bytes. So that particular thing you have to remember. So for each and every data type you count the size, and that size you then sum it up, and then that is the space that occupied by the each and every structure variable whenever you declare. So this is just a blueprint, and I will follow it with the declaration of the variables also. Just see, this is an example to struct person, character, name of 50, some personal identification that is declared as integer, then salary, float. Likewise, as many data items or else members as you want, you can put it inside the structure with appropriate data types. This is the check your progress 1. Write structure declarations for the following. So you just declare the structure, that's enough. So here see the syntax. Book is the structure tag, author 1, author 2. So here both these things you will be taking the character arrays, then title of the book, once again character array, publisher, once again character array, volume you may take int, year you may take int, and then price you may take float. So just to try the structure declarations for all these examples given over here. So book, employee, student, teacher, telephone, and then country. Just try it. Then we will proceed on to the structure variables. So earlier we had designed only the blueprint. So actual variable needs to be declared. So the same student I had taken over here, structure student, and then 4 data members I had taken. Those are called as the members of that student structure. And then down you can see we had used the keyword once again struct a tag name, that is student, and here we are just declaring the variables. If you want to declare a as integer, what you will do in C programming? Int a semicolon. Suppose if b as float, float b semicolon. But here you are declaring a structure variable. So the keyword should follow, then the structure tag should follow. So both of them are necessary. Then you have to write the variables. Student 1, student 2, as many as you want to use it in the program. So the alternate way is struct. You can look here, roll number, name, once again the same thing. And then you can directly, there the student is missing, you have to write the student also, stud1, comma, student 2, comma, student t. Directly also you can write. There the student, struct student is missing. So you have to remember there is a typographical error. Struct student, then the curly brace opens. Student is missing, just write down the student also. Then directly also you can declare the variables after the curly braces end. So that you have to take care. So either of the ways is a right way, like this one. After declaring the structure, complete structure, then you are using the keyword and then you are declaring the variables. Here directly you are doing it. There the student is missing, just write struct student. This is the check your progress for the second session. Like earlier I had given only to give the template kind of thing. Here create 3 structure variables for each structure declared in check your progress 1. So I had given over there some 6 examples. So for all the 6 examples, just create 3 structure variables. Then how to access the members of a structure? So structure members are accessed using the structure member operator, that is dot operator. So it is not a direct a variable like int a. A can be used, A can be assigned, A can be given a value during the program, due course of the program. However, whenever you want to access the member of a structure, that is inside the structure, whatever the member that you had declared. So whenever you want to use that particular, whenever you want to access the member of a structure, you have to use the dot operator between the structure name and the member name. Suppose student is there and inside there is a member called as roll number. So student, suppose if a variable is declared as stud1, stud1 dot roll number, stud2 dot roll number. Likewise, you have to access the members. So here you can see the syntax given at the end, structure variable dot member name. Suppose if employee is there and the variables are emp1, emp2, emp3 and id is there, then emp1 dot id, emp2 dot id, emp3 dot id are the various kinds of things you will be accessing. So you have to remember that in order to access the member of a structure, dot operator is necessary in between the structure variable and the member name. So initializing the structure variables. So we had seen in the earlier sessions that we had assigned the variables, or we had initialized the arrays also. So here also structure variables can be initialized at the starting of the program. Like for example, here a sale structure is taken with 3 items, data items or else members. One is the customer's name, item, then amount. So first one is an array, second one is also, item is also an array, amount is float. So here one structure variable is declared, that is my sale, struct sale, my sale is the variable. So in order to initialize that my sale, you have to initialize 3 items. One is the name of that particular company or customer, you can say, item and then amount. So first 2 are character arrays, that's the reason why we had put it in the inverted commas. So whenever you want to initialize the structure variables, you have to initialize in between a curly brace. You can see here, struct sale my sale is equal to, that is what we are initializing the variable my sale with 3 of the members. First customer equal to double quotes, we had given XYZ Industries, then item is tools kit and the price is, as it is float, we had given 600.00. And then you have to once again end it with the curly brace and a semicolon. Hope you had understood till this particular point. What we had done, we had created a template, or else you can call it as a blueprint for the structure. We had declared some variables, then we had seen how to access the members of the structure with each and every variable. And here in as the 4th agenda, we are seeing the initialization of the structure variables. So let's have an example program in totality. Like this is the main program, and here we are trying to declare a structure struct point. Then it has 2 members inside, one is int x and int y. So combinedly also we can like declare the members int x comma y, and then p1 is the structure variable we are taking. So struct point p1 we had declared the start of the program. Then how to access the members, p1 dot x, here we are initializing it to 20, and then p1 dot y equal to 10, printf x equal to y equal to p1 dot x and p1 dot y. So this is a simple program wherein which you can write and test and see the output just to print the coordinates. So this is the second example. There you had initialized directly within the inside the program. Here we are taking the value x coordinate from the user, y coordinate from the user, and then trying to print x and y coordinates of p1 structure variable. So then Program to illustrate to access the values of the structure initialized with some initial values. This is the second example wherein which a telephone structure is declared at the top, and then a variable TELE is the structure variable you had taken, and then appropriate data types you had taken in the inside the members, and then it is been initialized at the down. You can see in the main program struct telephone tele equal to, you are initializing the telephone, customer code, customer name, that is character array, customer address, once again character array, then bill amount. So in this way we can initialize the values, and then you can print the values also. So here you can observe whenever we are trying to access or else print the appropriate telephone number, customer code, customer name, etc., you can see the dot operator is being used along with the structure variable TELE dot tele number, and then in order to print the customer code, once again the structure variable TELE dot then customer code. So you can observe over here that whenever we want to access the members of the structure, we have to use the structure variable dot and then members of the structure. So you can just write simple programs to check check your progress to initialize values inside the program. This is one option, you can just check, and then to scan the values from the user and display, that is to take the values from the user and display. Both the things you try it for all the 6 examples, so that you will have a good practice how to declare, define variables, and then access the variables, initialize the variables inside the structure, and then or else you can take the values from the user and then printf the values whatever that is been scanned during the program. Instead of using struct, then struct tag name and then variables, struct keyword and struct tag name, we can use a typedef keyword. This typedef is nothing but it is a keyword to create an alias name for data types. So it is commonly used with structures to simplify the syntax of declaring variables. Just we will try to understand with the help of an example. So normally we will write, the left side is the normal kind of thing, struct distance, integer feet, float inch, this is the structure, int main, then we are declaring the variables d1 and d2. So whenever you are declaring the structure variables d1 and d2, you are using the keyword struct struct, and then the struct tag name, that is tag, that is distance. So instead of these two, struct and distance, write a keyword typedef before the struct keyword. You can see it on the right side, just to see the difference. On the first line, instead of writing struct distance, you are including another keyword, that is in order to get an alias name, we are using typedef, then structure distance. So whenever you want to write, and we are keeping a different name, you can see over there distances, it is ending with distances. The distances is not a structure variable. The distances is a alias name of struct distance. Instead of writing struct distance, what we are trying to write? Distances. So down you can see in the program, main program, distances d1, d2, those are the structure variables. So instead of writing struct distance, it is being replaced with distances. Here we had given a alias name called as distances. So wherever you write distances, that itself understand that struct distance instead of distances. So this is how you have to write the typedef inside the program, C program, in order to give the alias name for the structures. So as we had seen the control statement, nested control statements in our earlier session, nested structures are also possible. Nested structure in C program is nothing but structure within the structure. So whenever that itself means that one of the member or one or more members can be structures themselves inside the structure declaration. So we will understand it with one example also. One structure can be declared inside other structure as we declare structure members inside a structure. Similar, int x, int y, like character name of 20. Likewise, instead of a simple data type declarations, a structure also can be declared inside the structure as a member of that structure. The structure variables can be a normal structure variable or a pointer variable to access the data. Pointers we will understand in the next session. So just see here a simple example given over here. The complete program is written here, includes then student college detail. Here you can see one structure is student underscore college underscore detail. So in that structure the members are college ID, college name. Just remember, only college ID, college number. This is wrapped up or else is been put as one structure, college ID, college name. Coming to the second structure declaration, you can see here struct student details. Here as usual, one an ID is been taken and the data type selected is integer, name a character array, then percentage float. So you can see whatever the structure earlier we had declared, that is been called in, that is been written inside struct student college underscore detail, and then here we had defined one variable also, stu underscore data. So whenever you want to initialize, just see on the right, whenever you want to initialize the members of this stu data, stu underscore data, that is the structure variable we are taking. So stu underscore data dot id, that is as usual simple structure variable we are declaring, like student data and id, whatever the id that is there, like you can see over here, 1 is there, name is a character array, and then percentage we are taking as 90.5. Then comes the fourth member. Fourth member itself is a structure. So whenever you call that structure student underscore college underscore detail, it consists of two items. What are they? One is college underscore id and the other is college name. So whenever you want to access that particular college id and college name, you can see here stu underscore data dot clj underscore data dot college id. So you can see here two dots are being used, one for the regular stu data, one for the stu data, and the other for the clj underscore data. So first access the main word, that is stu underscore data dot clj data and then dot college id. In this way you have to access the members of the structure within the structures. Just once again go through this particular example and then practice this. This is called as the nested structures concept. Then let us see structures and arrays. So suppose in the earlier examples we had declared 2 or 3 variables as structure variables, student, s1, s2, s1, s2, s3, where student is a structure. So here you can see, suppose if there is a case wherein which 100 students are there and for each and every student you have to maintain the record, like all student name, enrollment number, marks for all the 5 subjects, then the total, average, percentage. For each and every students, if the class is of 100, so all the students, the record of all these items needs to be accessed. So for that reason we can use an array. array of structure variables. So you can see struct student, earlier we had used S1 comma S2. If there are 100, so just put it in the array STU of 100. So here the simple difference is that it is having an index. So whenever you want to access the first student, STU of 0 dot, then enrollment number, STU, then 1 dot, then ID. Likewise, all the student IDs can be accessed as well as corresponding records can be accessed with a simple index 0 to 99. So whenever we talk about this structure and arrays, if at all you want to take the data from the user, what you will be doing? It is a single array, single dimensional array. So you have to put one simple loop. So in order to take the inputs from the user, you have to initialize a for loop or else a while loop and put the index and set the limits 0 to 99. Then all the data can be scanned inside. Suppose if you want to print the details of all the students, whatever the data that is available onto the screen, then also you write one for loop, put the limits and then display the things. So for example, you can see here, earlier the example is for 3 students, just I had wrote struct students STUD 1, 2, 3, likewise we had used. But here if the student size is 20, I had kept it in the array form, variables in the structure variables in the form of a array, struct student, that is common to both. Then here I am using an index, or else you can call it as an array STUD of 20 size. So you can go through this particular program. This program is nothing but we have declared a structure on the top, that is student structure with 4 members, roll number, name, course, marks obtained, and then we are trying it to do for 20 students. We have to take the inputs from the user for all the 20 students, for all the data members, roll number, name, course and then marks obtained for all the students. And then we have to display the data. So here you can see one simple loop is been used, enter the student data one by one, and then we are using a simple loop in order to capture the data inside the program, that is 0 to 19. The index starts from 0. So STUD of 0 to STUD of 19 are to be accessed. So we had kept it in the loop form, and then all the 20 items, 4 members data are been captured. Then this is the display, wherein which whatever the data that is been captured, just we want to display it on the screen for all the 20 students. So here you can observe it is a kind of record access. So students one by one, for all the 20 students, you are capturing the roll number, then name of the student, course and then marks, course name and then marks. So for all the students, this particular record one by one has been created and we have been displaying the data. So structures as function arguments. Earlier when we are studying the functions concept, we had seen 3 categories of functions, that is functions with no parameters, and then functions with some parameters, and then functions with parameters and display also. So there are 3 categories of functions. Then suppose if you want to send a structure as it is to the function as a function argument, you can do. So whenever we are talking about the functions concept, we have to take care of the return data type. That is, suppose if you want to have the value of int as the return data type, appropriately you have to put it as int return data type over there. Likewise float, likewise all the primitive data types, whatever those are there, whenever you are returning the value, you have to take care of the return value. The same thing you have to put it as a return data type. That is the keyword that you have to use whenever you define a function. So here you can see a simple program is given, include stdio.h, then declare and define a structure to hold the data. Here PER is the structure variable of struct data type. Then it is having 3 members: amount, first name and last name. One particular function is declared. You can observe print underscore PER, and inside you can see the complete. We are passing a structure as an argument in this function, struct data x. So whenever we want to use the functions, we have to declare it at the top. That is what we had done over here. So void is, it is returning nothing, so void we had used print underscore per, that is the function name, and then the arguments that it will take receive is the structure, not a simple int or float or something else. It is directly receiving the complete structure. So printf, enter the donor's first and last name separated by a space, that we are capturing per.fname, per.last name, enter the amount donated in rupees. We are scanning both the values, and we are calling a function print underscore per. Within the braces you can see the structure variable per, that is total. In total the structure is been passed as an argument. So whenever we pass this particular argument, once again the receiving function, you can see it down, it should also contain a structure in order to receive as it is. So per is a structure variable, and down you can see with the void function struct data x. So that is also a structure. So whatever you are sending that particular structure per as it is, that is being copied into the struct data x, and then it follows it executes that function. And this particular function is not returning back any value, so we had written void. It is a simple printf function. Whatever the values that have been captured in the main program, we are trying to print it. It is a print function, print of the structure members. So simple, this is simple. So here you can see void means it is not giving any return data type, but whenever you want to receive that structure as it is, so inside that arguments you just observe the complete structure is been given. Likewise you can try this particular second example also, a simple example wherein which 3 functions are being used. One function for struct get data, and then the second function is for wages, and then only 2 functions, 2 function prototypes. One is to get data and the second is to calculate the wages and display. This particular thing you please try to understand and have it as a check your progress for. So before concluding session, let us recap what we had understood today. We had seen what is the definition for a structure, when to use, why to use, how to declare, then how to take the variables, how to take the initial values of that particular structures whenever you want to give it in the main program during the program. Then we had seen structures and arrays, and just we had seen the nested structures, and then how to pass a structure as an argument to a function. Hope you have understood this unit 9. In the next session I will continue with the pointers. Just take the questions whatever I had given in check your progress 1, 2, 3, and also the last program, that is the arguments passed on to a function, as the assignment, and please do it and practice. With this I will conclude the session. Thank you.